Hello, dear young minds. Sixth video of the chapter motion. In this video, we'll be seeing about a graphical representation of motion. Right? You must be wondering what is this graphical representation of motion. We have different kinds of motion, right? What kind of motions you have studied till now? You have studied uniform motion, and you have studied non-uniform motion, right? And in this uniform motion only, in non-uniform motion there will be so many types of motions. All right. I want to bring in the concept of acceleration also, displacement also. All right. First of all, let me rub it off. Graphical representation means whatever this motion is happening, no, so that motion has to be represented in the form of graphs. Okay, you must be having rough idea about graphs, no? This is a y-axis, all right, and this is a x-axis. You have idea about all these things, no? All right, so let me rub it off because it came down. So you have that idea, no? So those graphs and all we'll be studying about. The first graph what we study is displacement time graphs, and this is also known as a st graph, because s means a displacement and t means time. That's why displacement time graph. And this is also known as a position time graph. What is this? Position time graph. All right. Okay, fine. And next one is velocity time graph. Velocity time graph is also known as v-tgraphs. All right, or just v-t graph. V means velocity, t means time, v-t graph. All right, both these graphs will be studying. That is st graph and another one is v-t graph. All right, let us choose this first one, st graph first. Then we'll discuss. Okay, I will be using this car again and again to explain you that explain you a few things. Okay, all right. So we are studying about st graphs now. In that st graph, let us see the first one. Okay, it has to be explained with the help of an example. For example, there is a boy standing here. Okay, so this car is at some distance. We don't know how much distance. Let me take this as a x meter. Okay, all right. And he observed this car for time period. Okay, for a time, for example, 0 to 10 seconds he observed. All right, then he found out that this car was here only. I mean, it was not moving, it was at rest. Okay, it was not moving, it was standing. That means when he saw for 0 to 10 seconds, it was at a distance of x meter, that is for sure. Okay, it was not moving. Now he observed it for 10 to 20 seconds. All right, again it was at the same position, that is x position only. All right, it was not moving forward and it was not coming back also. Moving forward and coming back, both kinds of motions were not there. Then again he observed this from 20 to 30 seconds, then 30 to 40 seconds. He kept on observing, and for all these he found out that position is not changing. Position is not changing, or position is constant. Then definitely is definitely this body or this car, definitely we can say that this car, whatever this car is there, this is at rest. All right, now how to represent this in the form of graph? That's very important thing. Okay, let me take this as a y-axis. All right, and this one as the x-axis. Clear, no? Y-axis and x-axis, you definitely have idea about all these things. All right, let me change the color and show you. This is x-axis and this is y-axis, and here only in displacement time graph, what we are writing, instead of x we write t. All right, and instead of y we write s. So what does it mean? St graph means it's a graph in which x-axis is represented with what? X-axis is represented with time. All right, and whatever this y-axis is there, no, this y-axis is represented with a displacement means yes. All right, so this is the meaning of st graph. If somebody asks you what is st graph, then you should be able to say that it's a graph in which x-axis is represented with time and y-axis is represented with displacement. All right, so this is the definition of st graph. And when you observe this, and if you draw the graph here, so how it will come? 0 to 10 let me mark it with red only, it looks nice. All right, so 0 to 10 second you observed, and the car was at x meter. X meter as in here is let me take this as x. Okay, let me take this as x. 0 to 10 seconds when it was observed, it was x only, and 10 to 20 also it was at x only, and 20 to 30 also it was at x only. And if you draw any graph like this, you'll get a straight line, no? All right, you must have studied all these details in a pair of linear equations in two variables, how to draw the graph. So if you keep on observing 40 seconds, 50 seconds, 60 seconds, still the body is at rest, no? So this is the graph for what? This is the graph for the body at rest. Okay, if somebody asks you, draw displacement time graph for body at rest, means you should be able to draw this graph. All right, this is the first graph what we have got. All right, I hope it is clear. Let us move on to the second graph. Let us have a look at this second graph now. Okay, second graph that is known as uniform motion. We'll come to that. All right, so here is the y-axis and here is the x-axis. All right, fine. So here we are going to get this as s and this as t, and definitely this point is origin and this is 0. Now same car. Okay, whatever this car is there, no, let me copy it down so that I can paste it to show you some kind of motion. All right, now for example the car is pasted here. All right, now here similarly the boy is observing. Now when he was observing, it was here, and he observed this for time period, for example 0 to 10 seconds he observed, and he found that from this point the car has moved like this. For let me take 5 meter, it has moved. Okay, now this car, whatever this car is there, no, so this car has come here. All right, it has come to this place. Now here it has come 5 meters. All right, in how many seconds? In 0 to 10 seconds he observed the car moves for a displacement. We can show this as yes is displacement. He observed it for 10 seconds, 0 to 10 seconds, and he got to know that it has moved for 5 meter. All right, similarly if you observe it from 10 to 20, I mean another 10 seconds, then again he found that this car what was here, no, so it got again displaced. I mean it came front. I mean there is no space to show here, otherwise I would have shown. So now the car has come here. All right, this car. Okay, simply I'm drawing here. All right, so that car has come here. I mean this not here, I mean this point, again 5 meters it has come. Like that, for every 10 seconds he kept on observing. Okay, he kept on observing, and every 10 seconds it is going 5 meters. 0 to 10 seconds when he observed, he went for that car went for 5 meter, and here also 5 meter, here also 5 meter, here also 5 meter. For every 10 seconds, I mean car is going for how many meters? Car is going for 5 meters. All right, initially it was at rest, it was not at all moving, but here it is moving in the forward direction. Okay, every 1 second, I mean every 10 second 5 meters, every 10 seconds 5 meter, every 10 second 5 meter, it is going like this. Now what kind of motion it is? It is definitely uniform motion, you know that, but how the graph will come? Let us observe the graph here. All right, so 0 to 10 second, then 10 to 20 seconds, 20 to 30 second, 30 to 40, 40 to 50, and here distance is like let me take this as 1 5, this as another 5, this as another 5, and this one is another 5. So if you take like this, 0 to 10, how much it has moved? 5 meter. 0 to 10 means 5 meters it has moved, and 10 to 20 another 5 meter, means total it will become 10, no, I mean we have to mention it as 10, 15, 20 actually. Okay, don't see that 10 to 20 5 meter means you have to mark the point here 10 to 20. No, another 5 meters. No, initially it moved for 5 meter, another 5 meter, then another 5 meter, then another 5 meter. If you join all these points, you'll get a straight line like this, which is passing through the origin. And definitely time cannot be negative, and displacement cannot be negative, so that's why this part won't come. So that's why whatever graph is happening, no, so that graph has to happen in the first quadrant only. All right, so this is called as what? This is the graph for uniform motion. All right, so this is the graph for uniform motion. I hope it is clear. All right, so this was the graph at rest, and this is the graph at uniform motion. Now similarly, if I draw any graph like this, I mean look at this, for example this is y-axis, x-axis, this is time, and this is displacement. If the graph is like this, for example, look at this, if the graph is like this, I mean it has become like this. Now what is happening here, if you take the timing and all, okay, all right, if you take 0 seconds, then 10 seconds, then 10 to 20, 20 to 30, 30 to 40, 40 to 50, something like that, you will see that from 0 to 10 it has moved very less distance. I mean very less displaced, because it is not going above, no, and 10 to 20 also same, 20 to 30 also same, 30 to 40 also same, but 40 to 50 suddenly it has increased. Now what kind of motion it is? It is definitely non-uniform motion. So whatever I have shown here is non-uniform motion. So this is the graph for non-uniform motion. All right, so these are the only graphs which are there in displacement time graph, which you need to understand. Definitely one more thing, uniform motion means definitely it should be, the body should be moving at a constant speed, correct? No, so draw the displacement time graph for constant speed. If they're asking means you should be able to draw this graph. All right, if they're asking draw the graph for non-uniform motion, you will draw that. But for sure non-uniform motion means what is this, a variable speed. Okay, what is this, variable speed? Speed is changing, that's why non-uniform motion is happening here. Initially the speed is very less, but afterwards speed has increased suddenly. But here it is not like that, everywhere the speed is same, I mean constantly it is changing, correct? No, so I mean constantly changing as in constant speed. Displacement is in every 10 second 5 meter, every 10 second 5 meter means don't you think it is I mean it is uniform motion, and definitely the speed must be constant. All right, I hope it is clear. All right, so here also it is non-uniform motion means it is variable speed. All right, so if you want to take the example of that car, I don't want to copy and paste that car anymore. Okay, this car was here. All right, here was the person observing. He observed it for example 0 to 10 seconds he observed, and this car moved for 10 meter, for example. It has come here. Okay, how much it has moved? It has moved for 10 meter. All right, so then afterwards he observed this car from 10 to 20 seconds, I mean another 10 seconds, and he found that this car has moved only only 5 meters. All right, so in this starting 10 seconds it is moving 10 meter, in the next 10 seconds it is going 5 meter, and in the next 10 seconds it may go for 15 meter. All right, in the next seconds it may be at rest. Are you getting my point? Are you understanding? Okay, so I mean every time interval, so distance is going to change. So what kind of motion it is? It is non-uniform motion. Non-uniform motion means variable speed also. So this is the explanation of what? This is the explanation of displacement time graph. All right, I hope it is clear. Now coming there is a lot more to study from this displacement time graph, but first of all let's get into this vt graphs first. All right, so velocity time graph, we'll study about velocity time graph, and afterwards we'll discuss in detail about other things also. All right, velocity time graph means on x-axis time is fixed. Okay, on x-axis time will be there, that is for sure, and on the y-axis what will be there? On the y-axis velocity will be there. This time displacement won't be there, velocity will be there. All right, the first graph what we are going to study here is look at this graph, try to understand this. Okay, this is time and this is velocity, and if I draw any straight line like this, which is parallel to this time axis, one straight line. All right, what kind of motion it is? Don't say that it is at rest. Okay, at rest if you say, it will become wrong. So how to analyze this graph? Now look at this for 0 to 10 seconds, and 10 to 20, 20 to 30, 30 to 40 if it is there, and the velocity has become constant. Like let us take 80 meter per second. Okay, 0 to 10 second also what was the velocity? 80 meter per second. 10 to 20 also what was the velocity? 80 meter per second. Then 20 to 30 again 80 meter per second. Then 30 to 40, 80. Everywhere the velocity is same, no? So if velocity is same means don't you think it is constant velocity? Don't you think this is a graph for constant velocity? Okay, don't think that it is at rest, it is constant velocity graph. All right, now tell me one more explanation. If velocity is constant means what will be the acceleration? Acceleration will be 0, because acceleration means what? Acceleration means rate of change of velocity. In the last video I have explained that. Okay, if you don't know about acceleration, the link is in the description. Motion 1, motion 2, motion 3, motion 4, 5, this is 6th, right? So we are coming all continuously. So if you should be watching all these videos continuously so that you understand. So constant velocity means definitely the acceleration is 0. All right, so it is clear. So constant velocity, if they're asking, draw this graph. Acceleration 0 also, if they're asking, draw this graph only. All right, then moving forward, let's go on to the second graph. For example, the graph is like this. Here is t, here is v. Now look at this, the graph is like this. Now what kind of graph it is? Don't you think it is increasing velocity? Okay, if you take all the points and all, 0 to 10 you are taking, and 10 to 20, 20 to 30, 30 to 40, 40 to 50 seconds. Okay, this is in seconds, and this is in a meter per second. Okay, so 0 to 10 seconds you observed the velocity was like 1 meter per second. all right. And afterwards 10 to 20 you have observed, I mean 0 to 10 it has become 1 meter per second. Then 0 to 20 if you observe, okay, this is the way to see this point now. So x axis up to 10 seconds, and y axis it is 1 meter per second. Then 10 to 20 if you observe, it has become 2 meter per second. Okay, all right. So 20 to 30 if you are observing, it is becoming 3 meter per second. All right. So for every 10 seconds, now look at this, for every 10 seconds, what is happening, the velocity initially it was 1, and afterwards it has become 2, and afterwards it has become 3, right? All right, please observe this. Okay, observe this, how it is increasing 1, then afterwards it has become 2, then 3. I mean definitely the velocity is increasing. Okay, this graph represents what? Increasing velocity with time. But how that velocity is increasing? That is uniformly increasing. Okay, I mean for every 10 seconds 1 meter per second, for every 10 second one more increase. 20 to 30 another 10 seconds one is increase. See, look at this, uniformly it is increasing. For every 10 seconds 1 meter per second is increasing, so that is uniformly increasing velocity. All right, if velocity is I mean increasing uniformly, means what is the acceleration? Acceleration will be constant. Okay, don't say that zero acceleration, constant acceleration will be there. Why constant acceleration? Look at this, velocity is increasing, no? Velocity is increasing, I mean that too, how it is increasing? Uniformly it is increasing, means acceleration will be constant. Look at this, if you want to go for mathematically and solve this, then also it is possible. See, 0 to 10 when you take, at 0 what was, at 0 second what was the velocity? 0 meter per second. At 10 second what is the velocity? 1 meter per second. Final velocity is 1 and initial velocity is 0. Then divided by time is 10 minus 0. So what you will get? You will get 1 by 10. All right, up to this point I am talking up to point A. If you see up to point B, from A to B, what will happen here? A to B. So what is the velocity at A? It is 1 meter per second. What is the velocity at this point B? 2 meter per second. Final is 2, initial is 1, and divided by time is 20 minus 10. Here you have to consider, no, 20 to 10, so it becomes what? 1 by 10. And again B to C means here it is 30 and here it is 20. 30 minus 3 and 2, 3 minus 2 is again 1. All right, divided by time is 30 minus 20 is 10. Look at this, acceleration wherever you are calculating, no, that acceleration is constant. All right, so simply I'm saying, if any second graph, now we are studying about second graph, so if any graph is like this, so it is like what is this? Definitely I have written here, so just to mention that uniformly, I mean it should be mentioned. Okay, so this should be V and this should be T, so definitely it is uniformly increasing velocity. That means constant acceleration is there. And one more thing you can write, what is that? Acceleration is positive acceleration, because velocity is increasing, means acceleration will be positive. So how many names are there for this graph? 3 names are there totally. You can write all those 3 names. What is that? Uniformly increasing velocity, definitely increasing velocity, but it is uniformly increasing velocity. All right, and acceleration is positive. All right, and acceleration is constant. All that I have explained. All right, now third one. So if you take third one, if you draw the graph like this is T and this is V, and if you draw any graph like this, straight line for example, otherwise you take this graph first. How about this? Definitely this is increasing velocity, there is no doubt in that. Okay, definitely it is increasing velocity, my dear children. This is increasing velocity for sure. But how it is increasing? It is increasing non-uniformly. So that's why what is this? A non-uniformly increasing velocity. All right, and increasing velocity means acceleration will be positive, but whatever this acceleration is there, it is not constant. Look at this, 0 to 10 second almost the body was at rest, and 10 to 20 seconds if you come slowly, it is increasing. 20 to 30, 30 to 40 if you see, I mean sudden jumps. Okay, here whatever it is there, regularity is not there. I mean look at this, suddenly it has increased. All right, so this is not uniform, so that is non-uniformly increasing velocity, and acceleration is positive, and acceleration is not constant. Acceleration is variable. If it is not constant, means acceleration is variable. All right, is it clear? I hope the third graph is also quite clear. Then fourth one is quite simple. Again, you have studied this already, T and V, and if it is coming like this, Now what is happening here, just tell me. The thing what is happening here is a velocity is decreasing, but how it is decreasing? So look here, 0 to 10 seconds, then 10 to 20. All right, so 0 to 10, 10 to 20, 20 to 30, 30 to 40. If you check all these velocities over here, okay, so they are decreasing for sure as the time is passing, but how they are decreasing? Uniformly. Here it was, for example, 40, and here it is 30, 20, 10, then 0. I mean, definitely this is a decreasing velocity, no doubt in this. Decreasing velocity, but how it is decreasing? Uniformly decreasing. Okay, uniformly decreasing velocity. So that is the name of this graph, uniformly decreasing velocity. All right, let me select this fully. Uniformly decreasing velocity, and decreasing velocity is there means acceleration will be negative and acceleration will be constant. Whenever there is uniformly changing velocity, no, acceleration is constant. As it is decreasing velocity, acceleration is negative. All right, fine. Yes, dear children, you have to link and you have to study. All right, let us see the fifth graph. The fifth graph looks like this. All right, this is t and this is v, and here it is. What is this? This is decreasing velocity for sure. For sure this is decreasing velocity, there is no doubt in that. But decreasing velocity, how it is decreasing? Non-uniformly. All right, non-uniformly decreasing velocity. So this is the first one, and definitely decreasing velocity means acceleration is negative. How about value of acceleration? Is it constant? No, it is not constant, it is variable, because it is non-uniformly decreasing velocity, no, so that's why acceleration is also variable. All right, I hope the concept of st graph and vt graph, st graph and vt graph, all these concepts, and how many graphs are there? We studied 3 graphs in st graph, and almost I think 5 graphs, 5 graphs in vt graph. So there are different names also. All right, so all those things we have studied. All right, so I hope you enjoyed this video, and this video will be quite useful to you. You please like the video, because that's how the YouTube gets to know that the content is good. And please share this good work with your friends, and don't forget to comment down below what you want to listen from us. All right, and please make it sure that you are subscribing to the channel, because your subscription gives us a lot of motivation to make this kind of content. All right, thank you very much. Have a good day, and bye bye.